So hi everyone. Good evening to all. Maybe you are watching from different countries. So good morning, good evening, good afternoon, and welcome to Networks King. So myself Pankaj, and I'll be your instructor for this SD-WAN Scriptella SD-WAN solution. So we'll cover entire SD-WAN as per the Cisco syllabus that whatever the topic they have recommended based on their syllabus will entirely cover that or module during this SD-WAN solution. So let's start about the SD-WAN. So before we start the SD-WAN and going to discuss anything further, we have to understand why this SD-WAN is very important nowadays and why everyone is start talking about this SD-WAN. So guys, whenever you're having any question, when I'm just explaining the things, just try to ask in chat. I'll review that chat and I'll try to answer, okay? Or you can just unmute yourself also and you can ask the question. There is no issue. So it's up to you. So now again, when we start with SD-WAN, so people are keep asking like why this SD-WAN is very important nowadays and why everyone is just talking about to use this SD-WAN. And why it is very, why it is very different from other WAN solution that we know as the legacy WAN solution, that is a wide area network. So earlier we were using or still using that is a wide area network, but now the new technology come that is known as the software defined wide area network. So there must be some, difference we have between the software defined wide area network and that is the legacy wide area network. That's why people are trying to, different industry, different companies, and everyone is talking about this SD-WAN technology. So we'll try to digest that thing and we'll try to compare what are the key differences between the legacy WAN and this SD-WAN solution. Okay, so this is our agenda, and in addition of that, we'll try to see how this SD-WAN can be simulated in the lab environment, and that is going to give you the real, hands-on experience while doing this learning. So let's say suppose you are the beginner and you are just planning to build your career in the SD-WAN, but you don't have that, platform to, do your hand dirty by, playing with the SD-WAN solution, because the major limitations we have, people not able to get the labs. So, and even they are not able to build the labs on system because we having a lot of limitation, hardware requirement, and that the software requirement, the licenses requirement. So here in this entire journey, you'll get the entire very good lab. You can see that the lab overview that is absolutely working here. So I'll just demonstrate how this lab has been set up, and this is the entire lab which is going to be demonstrated throughout the session. So in this lab, we having a different sites which I'm going to explain in very detail, and we having also controller and how they are connecting with the different MPLS internet environment, and how the sites are going to be integrated with the controller. So before going to talk about this lab more, we have to understand that technology. Then I'll just showcase about this lab, and I just go through about this lab also. So we'll do in the second half. So let's first half try to understand why SD-WAN is very important and what are the challenges we having the legacy WAN, and that's why that challenges can be overcome with this SD-WAN solution. So let me just focus about the legacy WAN first. So when we talk about the legacy WAN, so that was like still it is using and it was using, but majority of the organization are just going to do their digital transformation. So when they talk about a digital transformation, that means they are just going to upgrade their infrastructure. So there is a requirement. There is a requirement to upgrade their infrastructure, else they're probably not able to leverage the different technology, leverage the different application experience with the legacy environment. If we not going to upgrade our infrastructure, might be some application visibility we are not able to understand, not able to experience the right things about that application with the legacy WAN, or might be we have to go with a more higher cost to actually leverage that technologies. Okay. So I'm just referring that the clouds are like, boom in the market, and everyone talking about the cloud platform, that is SaaS applications. So that all, and in addition of that, people are talking about more about the work from home solution instead of the office environment. So earlier we having before COVID, the culture was everyone was going to office and they were utilizing their office network to do their jobs. And then again, they come back to home and then again next to go to office. But now things has been changed. So people are working from home. So how company can give the same environment, same security, same parameters, same kind of the everything what setup was in office while working on the home. So these all solution when they are talking to integrate together, that SD-WAN play a very vital role on it. Okay, because without SD-WAN, the solution is incomplete. So there are multiple solutions to achieve this all digital transformation, but SD-WAN is the one of the key component, and that's why without SD-WAN, the company can't grow in terms of the digital transformation. So now that is a challenges. Now that challenges can be overcome by the SD-WAN, and basically in addition of this digital transformation, we having the real-time challenges. So you can see that in legacy WAN, we having kind of the complexity in the operations, we having the higher cost in terms of the overall management, operations, devices placement, and building that our network or security infrastructures. Scalability is a more problem about that. They basically not able to understand the cloud applications, and based on the cloud they're not able to take certain actions, which probably we'll going to understand detail in this our discussion. Also they're having fragment security. That means let's say suppose you having a branch offices somewhere in the country, but you have to go to meet the security parameter to hub office, like hub location, or your colo location, or might be your data center, to just meet your security parameter. So till the branch to data center or the hub office, you don't have any security. Might be you are just using the MPLS circuit and you are just using that IP6 circuit. They just carry their traffic, but actual security enforcement, whatever the security parameter you have to enforce through the firewall, that probably you just have to be fragmented with different locations. But when you go with SD-WAN, that might be overcome. So in addition of that, limited application awareness. So earlier that legacy WAN was not able to understand what the application is going through their network, and based on that application they're not able to take any certain action on that. So that was also challenge. And bandwidth was one of the major challenge. Like let's say suppose we having a dual sites R1 and R2 on site, and we having a links, but still in some of the case we probably just utilize one of the link majority of the time, and once it goes down, then the another link come in a picture. So that we call the active passive solutions. So some cases we use the active solution also, but majority of the cases we use the active passive solution. And in that case, we just wasting our bandwidth on of the link, and we are not properly utilizing that. So that was also challenge. And also they having a disjoint solution, they are mix of the solutions, not very standard. So that was also challenges. But when you talk about the SD-WAN, these challenges is just going to be overcome, and that is going to be definitely mitigate. And they having very robust solution to just minimize these all overcomes. So these were the challenges. Now let's think how the SD-WAN was evolved, and how this all challenges, whatever we have from the legacy WAN, that can be overcome with the SD-WAN solution. So before going to discuss more in detail how this all solution can be, how these all challenges can be overcome with the SD-WAN solution, we have to understand how the idea was came. Let's suppose we are discussing about Cisco, how Cisco or Viptela is just discovered this idea in some based on the SDN architecture or concept, that SDN stand for the software defined network. And then after they just driven such kind of technology that known as the Viptela SD-WAN technology, and then how they have just built this technology. So we are just going to understand this part now. So let me just take one of the example. Let's say this is one of the router. You must guys have knowledge about this router. And this router basically might be this router before SD-WAN solution. This was one of the best router. We can say that the 76400 router, which having the capability, you can see that we having a modular router, and that means it having a capability. They can do very high throughput kind of the processing, because they process the high bandwidth. They use in the WAN edge technology to connection to different offices. We can apply this kind of router in data center or very hub location of the sites. So what was the core component in this router and how it was working? So earlier this was a design of the router, and every individual routers working like this way only. So basically, if you just try to see in this router architecture point of view, this router architecture having a main three parts. So first is the IO module that we call the input output module. So that we call input output module. And after this IO module, we having the control plane module. So basically this control plane module, that is just doing the control processing, control information. I'll talk more about that. And then after we having a switch fabric. Someone please mute yourself. I can see there is a background noise. So let me mute them. So there is a switch fabric. So let's understand how these three things are very important of any of the devices, not this particular router. If you just talk about any of the legacy router, switch, whatever we're having, like Cisco switch edge router, they're having a similar kind of the architecture. So what that mean? So if we are talking about the router having input output module, the first thing that means the port you are seeing here, they are called as the input output module. So that means your actual physical connection is going to be done via these ports. So might be on this port you connected the switch. This could be the switch, or might be on this switch. In this port you might connected to another router. This could be also possible. So below this router we might another switch is connected. Okay, and on this switch we might have PC connected, and this PC1 might be there is another PC is connected, that is a PC2. So you can see that the one traffic is coming from this PC, and it is going to land on this port. So this port is basically taking input of this packet. So taking input of this packet, and further after doing the processing via the control plane, hey, let's suppose this PC having any IP address. Let's suppose it's having IP address 10.10.2/24, and this PC want to talk with 192.168.10.10 of the IP address of the network from the same segment. So let's visualize in this way. This PC just landed the packet, just punted the packet on this particular interface, and based on this punting, what is going to happen? Basically, when the packet is going to build from this PC to this PC, the packet looks like in this way. The packet is going to look like in this way. They will contain the destination IP information 192.168.10.10, and it also having a source IP information. So this could be this type of packet you are going to form that. So this is your destination IP, and this could be the source IP. So what is going to happen once the packet is going to punt on this particular interface that known as the IO module, that is input output module. So because your packet is going to enter on this interface, so that is become the input packet, or we can say ingress packet. So the first thing this router is going to do that, they are just going to check that, is there any routing information we have in my routing table? So they are going to talk, this particular packet is going on the control plane, and they are just going to talk with the CPU central processing unit. Hey, do you have any routing information for this destination IP address? So it might say, yes, I have a routing information, or it might say, no, I don't have routing information. So in case if doesn't have routing information in this control plane for this destination, this packet is going to be dropped. This is not going to be processed. But in case if we have that routing information in my place, then the packet is definitely going to be processed. So once this is going to be processed by the control plane, so control plane find that, yes, I have this destination routing information in my table. Now you can just process this packet from this interface to go out. So it's tell that you can go, if you want to go on this destination, I have a routing table, and the next hop of this network is pointed toward this particular interface, and you can go and just reach to this destination. Then basically this control plane given the command or instruction to this packet, you can go via this port and then it going to the restore destination. So this is how your packet is going to process via the control plane. And now in this control plane, we're having two things known as the routing packet and another is a routed packet. So you have to understand the difference between routing packet and routed packet. So when we talk about the routing packets, that means whatever the scenario I just talked about based on the source and destination, the control information, whatever the control plane module is going to just process. So it is going to check that is there my routing table having this particular destination route available or not. So based on that, it is going to check the routing table, and after checking the routing table, and routing table can be built based on the OSPF, based on the EIGRP, okay, any, and BGP, could be a static routing, any protocol that could be happen, and based on that routing protocol, it is going to give you the exit interface to go out to destination. So this is how routing packet is going to be processed via the leveraging the feature of the routing protocol. And routing protocol, basically, when we build the routing protocol, they basically do two stuff that known as the RIB, routing information base, and then finally they build the FIB, so forwarding information base. So when you talk about the RIB means the collection of all type routes to reach any destinations. That is my routing information base. But when you talk about the FIB, that is the best route to reach that destination. So routing table, we having a complete information that we known as the RIB. But out of RIB, it also build a FIB. FIB, that means they just build one of the table that known as the forwarding information base, that having the very precise route inside of this FIB table. So whenever that packet come in the routers, they just check the FIB table. I have the entry to go this destination. What is my next hop interface? So it will quickly get the next hop interface to go out from the source to destination. So this is how the routing packet come in picture and how it is going to be built via the help of the routing protocol. And routing protocol is nothing, it's a RIB and FIB. Okay, so RIB is one thing, routing information base, and FIB is the forwarding information base. So that is one concept. Now, when we talk about that, the another thing that is the routed packet. So once we having the routing packet information, and now we know that my exit interface is going to be anyone, then actual the routed packet is going to process via the IO module from one interface ingress to egress port via that routed packet. So routed packet is going to be processed via the in to out. So that is a simple concept. Now overall this IO module and the control plane, they are just connected to its back plane. So back plane is nothing, just you think about, you just jack in and jack out any of the module from the switch or router, modular switch. So they having the ASICs and switch fabric, we call that in backend. So their chips are internally connected. So let's say suppose this is your, let me just clear this screen. So let's say suppose this is like we having this one of the module connected. So on backend side, it is also connected somewhere on the chip. So they are interconnected, or once the packet are going to process from this particular IO module, they are also talking in backend to switch fabric, how to switch that packet, how to give the control instruction, how they talk this IO module to control plane module. They basically talk via the switch fabric. So they are interconnected in the back side via the ASICs, or like we having a chipsets. So they understand the behavior for the IO module and control plane, and based on that they process the packets. So this is how the switch fabric is connected. So this was the original design. This was the original design from which basically the switch and router was working, and still they are working. So now how this same thing can be changed in the SD-WAN fabric. So let me just go there. Let me just clear it again. So the same concept still we understand right now. We having a router and switches, and router switches having this kind of the module. We having a switch fabric, we having control plane, IO module. So from this this concept, SD-WAN basically have done the things to just divide these all things in different places. So instead of the building in everything in one box, like a router or switch, they just do things. You can just split this box functionality with the different places. So that means IO module has one box, control plane have another box, and switch fabric have some other things. So switch fabric is just a medium to connect these control plane and IO module. So this is just one medium, because in this, these are just think about the separate box. They are divided in router, but they are connected via the one box, because backend side we having some chipsets. So this is the just one medium which is just passing one instruction to another module. So if something is coming for IO module, it is sending that instruction to get how to process this packet via the chipset to the control plane module, that is nothing, is a CPU. And based on that, further the packet is getting processing. So the same concept, SD-WAN, what they have done, they basically just split this entire concept in open way. So what they have done, they just remove this particular control plane from this box and put somewhere in one place. So that is known as the control plane. Okay, so that is known as the control plane. And now they also move the IO module in one place. So this IO module is placed in the one place. So they are located in different place, and in between they place one of the switch fabric, and that is connecting to these two things. So this is how SD-WAN was designed, from this particular one module to one box to open box in this kind of this design. So let me just see. I can see people are talking about this. There is some question. So, sir, hardware defined means software defined means sometimes voice is breaking. Noisy. Okay, so I'll talk like Nihar is asking, sir, what is software and hardware defined means? So Nihar, basically software defined mean like the things is working based on the software instruction. So like we are getting instruction from software, and based on that, the processing is going to happen, and some software is sitting in somewhere else and they are just giving the instruction, that is software defined. But if we're talking the hardware, so they're having the ASICs and hardware plane, and they're having the module dedicated. They just follow the instruction within the box, and based on that they're just going to process the packet. Okay, so let's say suppose this is my hardware switch and everything inside of this box. So this is my this box itself having my brain, we having the input output module, we having the fabric, switch fabric, which are just connecting to input output module to the control plane to switch fabric. And this is how the complete hardware architecture is one box, and it is processing entire packet. But if you talk about the software defined, so that is game is going to be changed, and something we have that we are going to split that entire box in three plane in three places, and they all are going to club together. And after clubbing, the instruction is coming from the control plane that is sitting in the somewhere in the control plane, and that having a capability, they give the instruction in different type of instruction, like software instruction or like your policy. They are just going to influence your entire network topology. So that you think about the software driven. Okay. So now let's going to the next on this same concept to splitting this box, how it is going to be split. So you can see that in this architecture, again, we having a control plane, we having the IO module, and also we having a switch fabric. So earlier in this box, these three modules was there. So while we having one box, this was the hardware, and it was the single box. It can be placed anywhere and it start working. But now when we talk about the SD-WAN, this is going to be changed. So my hardware is split in three ways. That is known as, one plane is known as the control plane, one is the switch fabric, one is the IO module. So what is that? So when you talk about the IO module, that means the actual your routers, the Cisco VH routers, you can see that the Cisco VH router, they are acting as a just IO module. That means input output module. That means they know use their brain, because earlier my router having the brain, you can see that earlier my router having the control plane and CPU central processing unit, they having a brain. So it was getting instruction from brain within the box. But here you can see that the VH is just a dummy devices. They don't have brain. So whenever it want to do any function, let's say suppose again I have a same scenario. Let's say suppose this is my one of the router. Let me just, so this is my one of the router. Just think about that. And this router having again somehow two PC are connected. Just think about very small topology just for the representation perspective. And these two PC having again 192.168.10.10/24, and this one having, let's say support 10.10.10.10/24. Again, these two want to communicate. So one port is connected on this PC, another port is connected on this PC. So your packet is going to input from this packet, this port, and going to be out from this port. But this router doesn't having capability to take, decision how to process this my packet. So what is going to happen? They need to communicate with control plane module. They need to again go to control plane module. Likewise, in my previous case, you see that if my packet was landing to any of the module on here, any of the IO module, they, before processing the packet, they have to go and check the routing information on their control plane. So that's why they get to know how to go out to destination. So in same scenario, again, the scenario is same, but the only difference is the router, what we have right now, they don't have brain. So now the brain is put it somewhere in the control plane. So now it is going to talk to the control plane to get to know how can I go out from one interface to another interface. So this is how your plane has been segregated. Now, the third thing we having, that is known as the switch fabric. So earlier, if you see that earlier router, the same concept router, we having a switch fabric, which was just, which was just this module. Before going to talk this module, they are going to switch fabric, and via switch fabric, it was coming to control plane. And when it was giving the reply, again, it was going to switch fabric, again, it's going to come on the IO module. So the combination of instruction, or we can say that the integrating these two modules, that switch fabric was helping to do that. The same behavior. Now this switch fabric has been replaced with their transport. So what is transport? That is nothing. That is your MPLS, internet, or whatever we having the media type. So that is going to become a switch fabric. So you can see that your router is dummy. Before going to communicate anything to any end devices, it always have to go to control plane, but via switch fabric. And that switch fabric is MPLS, internet, or any type of circuit. So that means that is your ISP lease line, or just ISP internet circuit, whatever you can think about that. So why this was not possible future, like in past, why this only come in a few years back? So the story was earlier your internet was not so much reliable. It was very like lossy. It was like no like bandwidth guarantee. But nowadays internet is very reliable. So that's why people are just using the internet as a switch fabric, because they know that now my internet having a very good bandwidth, they having a very less lossy pattern. So my packet can easily switch from the IO module to the control plane, and I can achieve the same thing what I was achieving from the previous case by using the one of the box. So till the time, this is the like we having a concept from the SD-WAN architecture to one router architecture. So let me just pause here. See, I can see people are asking some question. So can we draw a diagram with the hardware to? So Nilesh will definitely draw this diagram and all. Definitely will do that in later. No worry for that. So I can see Sunny is raising hand. So Sunny, what question we have? Can you just please ask? If you are having any question, I can see since long you raised your hand.
Good evening, sir.
Good evening. Yeah.
Hello, sir. Actually, I have just one question. Just you have say कि आपने यहाँ नीचे 192 1 IP दिए, 2 IPs दिए यहाँ पे.
हाँ, right,
फिफ्थ
okay,
डायग्राम्स पे।
yeah,
तो
yeah.
या वो आईपी एक 192 का लिया है, आपने 10 डॉट का लिया है, ए क्लास और सी क्लास का, वाई ऐसा क्यों, मतलब कि?
It could be any network. I have just taken two network just for the
ओके
sample example. It could be any network.
ओके ओके
There is no meaning of the class 1, class B, class C. I can
ओके
take
ओके
from class A network only to network like 10, 10, 10, 10, 10, 20, 20,
ओके
20 kind of network. It could be no, just it was an example. Okay.
ओके।
Just one
एंड सर
example.
ये
Okay.
जो एमपीएलएस एंड इंटरनेट एंड 4G, ये मतलब है क्या, ये इसमें ये पाथ मतलब जस्ट ये पाथ है इधर अपना कंट्रोल पैनल मॉड्यूल तक जाने के लिए?
Yes. So your understanding is correct. So you can see that in previous case, we having a control module and we having the IO module, and how they are interconnected between each other via the switch fabric. This was the only option. The switch fabric is connecting to these two module via the backplane. You can see that. So
जी
the
सर, यस
switch,
सर।
this fabric was joining together. So now my control plane, IO module, and switch fabric has been splitted. So after splitting, we again need someone who connect my control plane to IO module. So that again switch fabric is we have, but that switch fabric is not a physical or some kind of the hardware or chips or like we having a circuit behind the box. Earlier it was also circuit, like that was chipset circuit backend of the this module that are going to interconnect, but that replaced with that your MPLS internet circuit, that is known as a transport or ISP circuit. You can just think about this way. Okay. So this is how
ओके सर।
your closed architecture has become one open architecture. So this is how your closed architecture become open architecture, and by doing this, we having complete control management of the fabric via the controllers. So the devices sitting on the edge location or the side, they are just dummy. They don't have brain to think about that. They always rely to take instruction from that central locations. That is a controller. So this is like how the SD-WAN has been become an open frame in terms of the closed frame by referring one router example. So I hope till now you guys are clear. So
यस सर।
now, yeah.
Hello, sir. Good evening, sir. My name is Satish Kumar. I have one question, sir.
Yeah, Satish, tell me.
Sir, in case end side, sir, VA side, we are using a firewall, then it is possible to configure SD-WAN.
So you are talking instead of a VH, we are going to use a firewall, right?
Yeah.
So firewall is like I don't think I'm not sure in which context you are asking this question, because if you talk about the Cisco SD-WAN, they having inbuilt firewall inside of that VH itself. Okay, firewall feature you can leverage by the VH or like with the help of the vManage controller. So that feature is already available. But if you are referring to just configure any other firewall like the Palo Alto or other Fortinet, which having
Fortinet.
yes,
Yes,
so
sir.
that basically. So let me just clarify one more thing. So SD-WAN solution, what we are doing discussion, that is based on the Cisco. Okay, Cisco SD-WAN. Okay, that known as the Viptela. Okay, so these two are the same, but in addition of that, also we having a different SD-WAN solution. That Palo Alto having the SD-WAN solution. Okay, Fortinet also having the SD-WAN solution. We having the Velo Cloud SD-WAN solution, Versa SD-WAN solution, VMware SD-WAN solution. So we have a lot of SD-WAN solution. So if you having some other mindset about the Fortinet, so that is not going to be integrated in this fabric. This is completely only going to work with the Cisco environment, and Cisco boxes are going to be part of this SD-WAN fabric. But still, you can connect other firewalls feature in this SD-WAN fabric. Like when you can see in the labs, we having a firewalls might be the Cisco ASA, Palo Alto, I can replace it. That definitely going to work, but they are not going to function SD-WAN features. They are just going to do some kind of the firewalling thing. If you want with the SD-WAN side, you can do that also. So that is possible. Okay, so that is the one thing. Let me see. Suraj asking control and hardware special device. So Suraj, like controllers are basically it is just software devices. They are just going to be install in the cloud environment. It could be the hardware if you're going to install in the your own data center in the your servers. That could be the ESXi or KVM server that is going to be help to install that controller. So that could be also possible. Okay.
Hello, sir.
Yeah.
So I have one more question, sir. What is the difference between MPLS and SD-WAN? Both are the secure network.
Yeah, definitely. That both are the secure network. Definitely, it's a good question. So if we talk about the MPLS, so a little bit shall I explain? Then I'll explain this point again, or let me just explain. I was just about to come on this point also. So, but let me just explain. So when you talk about the MPLS, so MPLS is just, let's say suppose you having a two sites, R1 or R2, and they having this MPLS connection. Okay, so both having the MPLS connection. So you can think about that. In this MPLS connection, first thing, your connection from this particular site, let's say suppose this is your site, this is going to connect on this way, and let's say suppose you having somewhere on data center. Okay, let's suppose this is your data center. They're just going to connect via this way on this data center. So you having a private connections, and every location have to just purchase this MPLS, and they're definitely going to make the very private connections that is very secure. But the only thing, this link cost is very high. Okay, so the main problem is the cost is very high in terms of the MPLS. But definitely your goal is going to be achieved by the help of the MPLS with the in terms of the security. So that is definitely possible, but cost is going to be very high. So that is the one thing you have to take care in your consideration while doing the design. Now, other thing, what you have to take care, likewise, I mentioned that in my slide, the problem was that insufficient bandwidth or high cost, complex operations, or limited application aware. So let me tell about these all function. What is going to be happen in terms of the MPLS? How they are going to be, not exactly what SD-WAN can do. So in terms of the MPLS, if let's say suppose we having a scenario, this link having 100 Mbps, okay, and this link also having the 100 Mbps. So both are using the 100 Mbps, but in some of the case, might be one of the users sitting here. This user is sitting here, and this link is particularly active, and this is the passive. This is my normal scenario. I'm just talking about the normal design. So what is going to happen in this scenario, if this link is not going to be down, but somehow it having the packet loss? This could be the one option, we having the packet loss. So your traffic from user to destination server, might be your server is hosted somewhere here. It is keep going through this link to this server. It is keep going via this only. Okay. So by going this one, this user start facing experience. So application slowness. So it start, facing slowness. So in this scenario, what is going to happen? Probably your experience is not going to be good, and this router is not going to do automatic failover to the R2 because your link is not down. Might be you have configured the auto failover, but that is only going to happen if your link is going down. Then your BGP or whatever the protocol you are running, that is going to change the behavior, or then it is going to might be you're running the HSRP in LAN that going to track that link and then fail over the gateway to this router. That scenario is going to happen only if the link is going to down. But you can see that my link having a packet loss. That means the link is not completely down. So your packet flow is still going via this link only. User is facing slowness. So this is the major challenge in MPLS. Even you having the MPLS with a high cost, but you can't do auto failover. But if this is the SD-WAN solution, if in this same scenario, if we're having the SD-WAN solution, we having the two router again, but these are the SD-WAN router. Okay. And this is also SD-WAN router. And again, we having the packet loss. This is going to be changed automatically. You just have to configure your WAN transport or WAN design in this way. Whenever my loss or latency is going to below of the 80% of the threshold, just switch the traffic on another WAN. So this is possible. So this is the second difference. After cost, the failover mechanism or the flexibility of the network is going to be happen very, easily. Now other things, let's say suppose you are running in the active and active. So this link is basically not going to utilize unless this link was going to be down. So you can see that just you wasting your cost with this link. You are not able to utilize by this link. You can utilize that, but you have to do some kind of the load balancing, and you have to introduce some complexity of your network. But by the SD-WAN, you can easily, if you want to send some specific traffic from this link, you can send that. Some specific traffic from this link, you can easily send that. Based on the applications, you can do that. Based on the routes, you can do that. So everything, it is possible in terms of the SD-WAN solution. So hope you have in the broader idea, right? You got it? MPLS and like the WAN, what I talk about that, the SD-WAN, right? So these all basically we having a drawback like the this application awareness, bandwidth issues, disjoint solutions, higher cost, complex operations. So let's think about another scenario. Let's say suppose you having the another scenario, and we having a sites like router. These are the again router 2, and this is the one site which having this kind of the scenario where router are connected. So let's say suppose this is the one site 1, okay, and might be this is the MPLS site, and we having a similar site in different location, or this could be the like site 1 to site 200. So I have a 200 site and all are running the MPLS. But let's say suppose tomorrow you having a requirement to just upgrade any ACL. Let's say suppose you have to modify any ACL to all MPLS sites. So how you can do that? You have to probably go and log in each and every devices, all 200 devices or 400 devices, whatever having on the 200 sites, and you have to do the configuration manually one by one. But when this particular site become the SD-WAN site, and again we're having a 200 sites, probably you have to just go in one box and do this configuration in one go. So that is also very possible. So this is like we having a lot of feature that MPLS doesn't, like legacy WAN doesn't have that much feature in terms of the operation, in terms of the costs, in terms of the like bandwidth, in terms of the like cloud readiness, in terms of the like application awareness. So a lot of things we having right now in SD-WAN solution, which SD-WAN was not having that much solution. So similarly, after doing this, they basically what they have done, they have just divide this plane. After dividing this plane, what I just explained that, so they put some devices in the controller, some devices in control plane, and some devices on the IO module. So what those devices are? So transport, we understand, very easily understand, transport is just MPLS, internet, or whatever circuit we have. But when you talk about that, the infrastructure point of view, what type of control plane devices we have? So we having these devices. So we having a control plane devices that basically known as the vSmart, vManage, and vBond. So these three devices are part of the control plane. Okay. So they are just going to sit in the control plane. They having a responsibility to process the whatever the IO module instruction is going to become, and they are going to IO module is going to get the instruction from the control plane. Okay. And further, this control plane basically we high level see that control plane all three devices, but again they have sub devices in the some different plane. So in for time being, you just understand these devices are part of the control plane, but again every device is having different responsibility in doing some control things. So if you talk about the control plane purely, that is purely routing, and that routing is just done by the one box that is known as the vSmart. But we having another box vBond that known as the orchestration plane, and vManage is known as the management plane. We'll discuss more about that, what that mean later on, but just for now, you just understand we having a three devices part of the control plane, but we having another, again, we having a different role. But when we talk about the IO module, or like we having the data plane, we having the VS devices. This could be VS, this could be the CH. And these are the switch fabric. They are connecting to the control plane and data plane. So these are our architecture about this SD-WAN fabric. But again, we have to go in very depth to understand how it is going to be happen. So moving to next, after this, let me just brief you about the labs, how it looks like in terms of the real scenario. Okay. So you guys can see that we having a different sites here, and in different site, basically we having a control plane. Let me just show you. We having this is a part of the control plane. You can see that these are the devices: vManage, vBond, vSmart. Just forget about this one. But these three devices are part of a control plane, and these control plane are connected with the switch fabric, that is MPLS internet circuit. You can see that, and from this switch fabric, the other sites are also connected. You can see that we having a lot of sites. They are connected via this switch fabric. So this is how the switch fabric is our actual transport, and our control plane are here, and we having the different edges. So that is the input output module where the actual LAN is connected. Actual users are sitting on the different sites. So this is how our control plane, data plane, and switch fabric are integrated in terms of the SD-WAN. Yes, Nilesh, you can ask the question if you're having anything.
So Pankaj, hello.
Yeah, tell me.
Yeah, can you go to the diagram?
Yeah, sure, I can go. Yeah, tell me.
Yeah, so this vManage, vBond, vSmart. So is it a hardware or is it a VM or what is that?
So these are the just software they can install in the virtual environment, like your VMs that why I install in the VM right now, and it could be the cloud. It can be installed in the cloud also. So again, cloud also needs some kind of the platform to install this. So that could be the VM again. But these are the software that can be installed in the virtual environment, or might be there is no any hardware. Basically, they are the VM. Just think about the software appliance. They are just going to be installed in the any of the cloud solution like AWS, Azure, Alibaba, GCP, or can be the VM. But your routers VH can be your physical box or can be the virtual, both. But these are the pure software.
But
they are the pure software.
But there are devices as well, correct?
Sorry.
SD-WAN device, hardware device is also there, right?
Yes, SD-WAN hardware device that only that hardware can only come as a CH device or VH device. These two, CH or VH. These two devices could be the only hardware. Rest all three are the software.
So do we have to use this CH device as well as this vManage?
Yes.
So it is a combination of all four.
Yes, it is a combination. So just try to understand. We having, let me just explain you one more time. So we having these planes, okay? Let me just go. We having these planes. So if we talk about the control plane, on this plane, we going to use three devices. vManage, vBond, and vSmart. So these three devices are going to use the control plane. And this location, we are going to use that device known as the VH or could be the CH. So two type of device is going to use on the input output module, IO module, and these three devices are going to be used on the control plane. And these basically switch fabric is going to be used in the ISP transport. So this is how your connection is going to be built. So you understand? And this is only 5 devices is going to be used entire SD-WAN fabric. Okay. So let me just go a little bit on lab. So you can see that I just wanted to show you live lab how it is going to work. So with this particular vManage is one of the controller, and this is a single pane of glass. From sitting on this vManage, we can configure entire our site, entire our fabric. Okay. So right now this lab is fully configured for the just demonstration purpose, but definitely we will going to build a very scratch this entire lab again, because without understanding how the controller is going to be configured, how the site is going to be integrated with this switch fabric to this controller, you guys not going to understand the SD-WAN. So we start from very zero. Just we copy this lab, but the configuration is going to be done from very scratch, and all configuration, whatever you're saying, everything is just going to be done. Nothing is going to be untouched throughout the SD-WAN session. So let me just showcase you how this vManage looks like and how the sites are going to be connected. So right now all sites are up and working, and there should be operational on the vManage perspective. So let me just log in this. So I'll go on the GUI. So one more thing, guys, you have to take care in the consideration. Earlier might be having the very good experience on the CLI, might be you guys having the 10-year experience, 5-year experience, 15-year experience, I don't know. And you guys are more comfortable in the CLI. But the SD-WAN, when we're going to start learning on the SD-WAN, you just have to switch your mindset on the GUI, because the time has been changed now. So if even you can do the CLI stuff, there is no problem on the SD-WAN, but it's highly recommended to do each and everything in the GUI, because once you start doing the GUI, the looks, things like, everything looks like, very easy to you. Earlier, in early phase, might be you'll face some difficulties, but you, end of the day, you will start enjoying this GUI feature. So you can see that right now, I'm just trying to log in this, vManage. And in this vManage, this is my beautiful dashboard of the vManage. And in this vManage, you can see that total 5 site I have, site ID 3, 4, 5, and this is the site ID. We have 200. So total 5 site I have, and all 5 site I can see are up and working on this 5 edges, up and working on this, SD-WAN fabric. And we having this controllers. You can see that one we having the vSmart, one we having a vBond, one we having a vManage, and they are all green, up and working. So that means the controller are up right now, and then they up and working. So that means my fabric is completely up and working, and these controller are talking to the all VHs for different site locations. So whenever you just going to start the SD-WAN, your study, probably you just have to need first to set up the how the lab is going to be accessed, how the vManage is going to be accessed, and after going to vManage, how the dashboard is going to be looks like, and what information I have on the dashboards. So you can see that on my dashboard, we having each and everything, like is showing that the full WAN connectivity, partial site WAN connectivity, no WAN connectivity. So we can get the alert, alarm in dashboard itself. And also we can say that how many VH are health status, do we have any warning, error and all. So this is the powerful tool in name of the vManage. They can provide entire network visibility of your SD-WAN fabric. So earlier, before SD-WAN, probably you have to go on different site to check their health. So suppose I want to check what is my circuit status of these 2 links. So probably what I have to do, I have to go and log in this router. Suppose 5 site, 5 time I have to go and log in that. But the same thing, if I want to do on the SD-WAN, how can I do that? I simply go and click on that, okay, that router, and see how it is going to show you the live, circuit status. So I want to check my circuit status of this VH3. So no need to go and log in this router. I can go on my vManage, that is centrally, and after going on this, I can go here and click real-time device. Okay. So it will show me clearly entire health of the interfaces. So you can see that whatever the traffic, you can see here, this is my interface. Let me just check the name. So GE0/4 and GE0/3. These are the 2 interfaces connected to the MPLS and internet. I want to verify the health status. So here you can see that this is my GE0/2. So this is my interface GE0/2, and this is my GE0/3. So these are the like graphical view. It is giving how the interface looks like, and it is real time. If you want to just customize, take 7 days, 6 hour, 12 hour, 24 hour, even you can get it from here. And if you want to just select that 2 interfaces, not all, you can just do via here also. Just deselect that all interfaces, and only the interface information you will get the information, only 2 circuits. So you can see that it is showing how many received traffic we having in kbps and what is the transmit traffic we having in kbps on these 2 circuits. So this is how you can see that. If you want to get the top talker, you can get from here. If you want to take the flow, what the flow they are using in terms of the application, what they are using, you can get all detail from here. So this is the like beauty of the SD-WAN, which earlier we don't have. So earlier we have to go and do the each and every task on the individual router, but here now the game has been changed. Here you just have to log in to any of the dashboard. After logging to that dashboard, like that is a vManage dashboard, you can just go and check each and everything. Earlier, let's say suppose you have to log in this router. So I have to click and might be I have to do the SSH. So see, I have done and I'm just logging this router via CLI. So let's say suppose I want to do the configuration. I have to do log in each and every boxes individually by going to each and every locations. But if I have the vManage access, I no need to go each and every boxes by logging this SSH connection. Let me show you how it is going to be possible. So simply I go here, and after going in this here, you go in the SSH terminal, and after going SSH terminal, you want to log in the VS3, just click here. Just click here. You'll log in directly via the CLI. If you want to enjoy CLI, you can just go and log in here. See, I can do the same thing. So we having a one screen here. Let me just put the again password. See, this is a VS3. I can log in. I can log in. So I no need to go individual router to log in one by one. I can close it. No need. I want to log in VH Pro. Let me just click here. See that my dashboard is again my session is again created here. So I can log in again VH Pro. So how life is easy by doing the SD-WAN fabric jobs. So anything I want to just do the changes I can do here. I want to monitor I can do here with CLI and GUI both. Any configuration, let's suppose I want to push. Let's suppose I have to modify the any ACLs for the all routers. So no need to go individually on the on routers. I can create one template policy. So we having a template policy. We can just create it and we just apply on the all routers. That is going to be happen. So these are the overview I'm just giving because these things only you guys are able to understand once we start this classes and we go step by step how the things is working. So the first step, we have to understand entire functionality of the control plane, entire functionality of the data plane. So that means we theoretically have to understand what is the function of that vManage, what is the function of that VH, what is the function of the vSmart, what is the function of the vMont, what are the differences between orchestration plane, management plane, control plane, and data plane. Once you guys understand, then probably whatever I'm talking, you start visualizing how things is working. So without understanding the theoretical concept, probably you will be not able to understand entire SD-WAN fabric, how the operation is going to be working, what that means, templates, feature templates, device template, policies, how it is going to happen. So this is the way you guys can, do the things. In addition of that, let's suppose I'm just giving one of the very good example. Again, let's suppose you have in the iOS upgradation of the 100 routers. Let's suppose the legacy WAN. So how guys you are going to do the hardware upgradation, like software upgradation? You have to go on the every router. You have to just upload the iOS, then download, then one by one you have to do. Might be 10 engineer, 15 engineer going to require. It's going to be very long time to upgrade that. But if you're having SD-WAN, see how quick it can be done. So you just have to go software upgrade process. And once you're having the software upgrade, you're having 100 sites, just select all 100 sites and just upgrade the image. Okay, one go all site will be going to deploy. If it is going to just take 5 minutes, all 100 site is going to deploy in just 5 minutes. So how it is easy? Earlier it was very complex, just copy the image, send the FE on the site, do the iOS upgradation manually, but here the game is changed. So this is how, like, you can, I'm just giving the small feature so you guys can visualize the thing about the SD-WAN and the legacy WAN. And in addition of that, what else we have? Let's say suppose I want to see real-time monitoring. So let's say suppose earlier you have to do any kind of alarm monitoring, event monitoring. So probably you have to buy the third parties tools to do the monitoring, whether any alert I have, any link is going to down. But now no need to worry about that. That is going to save your cost. This vManage is going to save your cost. You have to just purchase this vManage, like I mean the SD-WAN fabric, and this feature is alarming, ticketing. You can just integrate with the ticketing tool, and this is just everything available here. You can see that real-time alarm it is showing, all alarm, all event. You can just see that what is going on through your network. So everything with the time with the graphical, you can just customize with the custom time, 7 days, 6 days, or 24 hour, or like 1 hour real time. You can see the events. So that is also possible. That was probably not possible on the legacy WAN. And that was only possible by purchasing the new third-party tools. That was incurring the cost. Okay. So this is like, how you can think about this. So apart from this, Suraj asking, sir, we can get, sir, can we also do routing like BGP with the GUI? Yes, Suraj. So like, see, everything we can configure, like even from the GUI. Let me just quickly show you guys. We having that, let me just create one template for you guys. You probably not understand if you're not background to the SD-WAN, but just wanted to demonstrate you guys how the things is going to be configured in terms of the routing protocols. Okay. So test template. So you can see that we having, not sorry, this one. Let me just create the feature template. So not device template. So I'm just quizzing you, so you just gain the confidence how that you are going to learn. So you can see that if I want to configure any routing protocols, so earlier might be you have to understand the routing protocol configuration from the CLI, but here no one worry about the CLI. If you don't know CLI, you can do the routing BGP, OSPF, GRP, static routing via the GUI itself. So let's say we have in the AAA configuration, we have in the NTP configuration. You guys must aware of the AAA accounting, authentication, authorization system, NTP protocols, BFD, security, OMP might you not aware. Definitely I'll tell that this is the SD-WAN protocol, overlay management protocol. We are going to discuss this one in our session. Is the SD-WAN learning. So that definitely you guys might not be aware about this, but I'm just assuming you guys are aware about AAA, archive, and BFD, NTP, security system is new for you guys. I know that. In addition of that, VPN configuration, probably you guys are not aware. Definitely I'm going to tell you. But see here is like things, OSPF, PIM, multicast, DSCP, BGP, that configuration we can do that. So let's suppose I want to do BGP configuration. I can do the BGP configuration by here. See that? So earlier it was the GUI, but here you can see that I want to shut my neighbor, yes or no. What is my remote AS number? What is my router ID? I want to propagate AS path. I can do that. Local preference I want to set. I can set that also by the help of the creating the routing route map and route policy also. That can also be possible. I want to redistribute some other routing protocol, that can be also done. I want to advertise a network in BGP, that also can be done. So everything, neighbor detail I want to put, earlier we putting the neighbor detail by defining the neighbor's address. That also can be done by putting neighbor detail here. You can see that I have to just put the neighbor ID, remote AS number, address, family. I want to shut, no shut. That every configuration I can do in the term of the BGP. Okay. So this is also possible. Everything can be done in the GUI. OSPF you want to configure, that also can be possible. See that here is the OSPF. I want to configure OSPF, similar. So what OSPF required? OSPF required router ID. You want to, use what is the distance for the external route. You want to set the metric. You want to distance for the interior route. You can set that also. You want to redistribute that also. You can redistribute that area. You can set that. Advanced, if you want to just do the originate, you can do that. Hold type timer policy. You want to apply that maximum hold time timer, millisecond, reference bandwidth for the cost calculation. So everything it can be done in the GUI also. But for this template creation, these are the key thing for the SD-WAN, policy and template. If you understand about the fabric, you understand about the policy and template, you will be the champion for the SD-WAN, because these are the key thing to understanding the templates. So you can see that in previous batches, I have created so many policies. So this is the previous lab. So you can see that we have created too many, feature templates. So, and this much template we are going to create in our lab also. And these are the device template also. So these are the device templates. So I have created a lot of feature template for different feature. Let me show you. So you can see that BGP configuration, banners, or some OSPF configuration also we have. And we can see that everything we just covered in our, configuration, VPN1 configuration, service VPN, transport VPN, dual site, single site. I'll explain what that means. In addition of that, I just configure a lot of policies also. So that you guys also do. I'll show you, and next you also see how many policy I have covered. That is like each and everything. TLOC, hub and spoke routing, hub and spoke via TLOC that we have created. TLOC based hub and spoke, application aware routing, extranet routing policy, direct internet policy, VPN membership policy, DIA local policy, VPN membership site-to-site policy, QoS policy, service insertion policy. See, so almost every policy, every type of the SD-WAN policy, I have just covered in entire session. Okay, this was my previous batch lab I'm showing you. And now this kind of the session you are going to get from this, upcoming batch also. So be ready, and I'm sure our journey is going to be very, interesting to, throughout all SD-WAN session. So I have done for today. Let me see if you guys any question. Let me say, Nilesh, is how it is useful for the work from home user. So Nilesh, right now the term is using, people are talking and might be you aware about that is a Sassy. Okay, secure access service edge. So when you talk about this solution, this is the Gartner recognized solution. They're having like 4 solutions. That is the SD-WAN and secure web gateway, SWG, and then we having another thing is like secure web gateway, SWG, and what else? I just forget the name too. So like
security.
Sorry?
Zero trust security.
Yeah, zero trust security. Okay, zero trust security. And one more thing we having total 4 of combination, SD-WAN, secure web gateway, and I just forget name. Okay, never mind. So that's Sassy component of this 4, and then after by doing this 4, we are just going on this, Sassy solution, and these are the quite interesting, and this is the future of that. So work from home user, once you're talking about this work from home user, they're leveraging that all features, and after applying this all feature, they are getting the similar experience what they were getting in the offices. Okay, so this is how SD-WAN is play a vital role in the Sassy solution, and it must be there. Okay. So Manoj is asking, can we do L2, L3 VPN? No, Manoj, L2, L3 VPN is not part of the SD-WAN. These are the separate topic that might you have to go and learn. If you want to learn in the MPLS and RC module, then it is going to be covered. Can we manage L2 switch? Wahid Khan, L2 switch we have in our topology, but I'm not sure what exactly you are referring to L2 switch. L2 switch we can discuss. There's nothing much to discuss in L2 switch. Just we have to understand the VLAN. So if you have the VLAN information, then you can just do that L2 stuff in the L2 switch. There is no problem. Farhan is asking automation. Yes, Farhan, automation is like one of the major parameter for the any of the organizations, because things to be automated. So SD-WAN, you can see that how automated itself. SD-WAN solution is the automated solution. Lot of things we can do from central location instead of doing the manual location one by one by doing the configuration. So that is also automated. So still we having the other automation feature that we can integrate this SD-WAN to some REST API, and that third-party application is going to talk with this our vManage with the REST API, and we can do a lot of automation also. So that is different, completely different automation module we have apart from this SD-WAN. So that is going to cover more about the automation. So Redmi, someone name is Redmi. So tomorrow there is no class. This class is purely start by 10 or 10:30 IST time. You guys just recommend, I'm okay with the 10 or 10:30 both. So we can just go with this on Saturday, Sunday, and you guys have to be ready minimum 2.5 hour daily classes on Saturday, Sunday. Maximum could be 3 hours, no more than that. But minimum 2.5 hours. I'm going to take these classes on weekend. So at least 5 hours on 2 days. Okay.
Yeah. Hello, this is Manoj here.
Yeah, Manoj.
Yeah, because I have joined also security parts. So showcase with security, sir. So his weekend classes is start from 9 p.m. So how can we manage? Because you.
So 9. This is a morning class, not evening class.
On Saturday,
Okay.
Sunday. It's a morning 10 a.m. or 10:30, whatever the time is convenient. Accordingly, we can proceed with that. It's a morning time.
Morning is perfect, not issue.
Yeah, it's a morning.
Yeah,
Just
morning. Okay, morning.
Yeah. So anything else, guys? You have to ask any question. If you feel you can ask it.
So Cisco has certification of this SD-WAN.
Yes, Cisco having official certification for this SD-WAN, and you guys are just going to cover this entire module let me show you. It's not saying. Let me see if we having. I'm just exactly showing the syllabus, what we have in the syllabus. So it's not showing Cisco SD-WAN. Just it is going to be shown now. Okay. So exactly whatever the topic we have, I'm not going to untouch any topic as per the official certification. So this is my like always, focus to just go with the official certification, because if you go with the official certification, you will not leave any topic. So let me see where it is. Okay, might be this one. So let me just quickly show you what exactly we are going to cover in this SD-WAN module also. So see that these are the total module we have: architecture, controller deployment, routing, router deployment, and policies, security, quality of service, management, operations. So let me just give you the overview. So in architecture, we are going to cover this entire, describe the SD-WAN architecture component like orchestration plane, management plane, control plane, data plane, TLOC, IPsec, GRE, vRoute, BFD, everything we are going to understand. In addition of that, you have to understand like what are the SaaS, IaaS, and co-location application. Like these are the cloud-based solutions. So at least you having understanding about that. So this is the architecture. Then after that, controller deployment. I'll show you and I'll deploy entire controller from very zero. Okay, so every controller is going to deploy in the very scratch. So you're having a very good experience how the controller is going to be deployed from scratch. Then after, we'll definitely just deploy controller in our like a KVM or hypervisor solution. So these are the EVNG solution. They are deployed in the, I believe, ESXi or KVM. So we are going to just install this controller on the EVNG, and we are just going to build from very scratch. Then after, we are just going to configure the certificate and just whitelisting the devices, troubleshooting the control plane connectivity within controller if you're having any issue. Then we are just going to understand. After that, we'll understand about the protocols, VRRP, OSPF, BGP, EIGRP, how they are going to work with this SD-WAN fabric, how the configuration is going to happen. So these all things are going to be happen in this section. In addition of that, we'll understand the tail of extension, dynamic tunnels, underlay overlay connectivity, what that means, onboarding of this, VS devices, orchestration with the zero touch provisioning, plug and play, what that means and how that is going to be happen with the SD-WAN fabric. Then data center and regional hub deployment, how it is going to happen. So each and every topics, I have dedicated module. So let me show you. So each and every topic I have dedicated module. So I'll just cover each and every module in very detailed way, so you guys can understand. In policy, you can see that we having a very less policy, just a VPN membership, control placing data policy. But I'll show you, in addition of that, how many policy I have covered. You can't even find this type of policy in syllabus itself. These are just talking 4 and 5 policies, but I have just more than 10 policy I have flavor given in this, my SD-WAN session in last one. That is also not part of syllabus. So you are going to very good understanding, because policy is the major thing. Policy and template. If you are going to understand policy, how it is going to work, then you just understand the entire fabric, concept. And if you are not going to understand policy and configuration of the boxes via the GUI, then probably something is missing, SD-WAN. So then after policy, we having the quality of service. We are just going to understand. So detailed quality of service. And security. Security is like my very favorite topic. So I'll explain how the IPS URL filtering, that like SSL, TLS, proxy, AMP, like how they are going to work with the SD-WAN fabric. So these all features are integrated with this SD-WAN fabric. So once you buy the SD-WAN solution, you can leverage these feature security parameter also by the SD-WAN. No need to worry about that. DNS security, secure web gateway. So that also we are going to understand how it is going to help. So because I was talking about Sassy, so Sassy is just not complete without this secure internet gateway, secure web gateway, or like URL filtering, IPS, IDS module, data filtering, data loss prevention. So these are all part of the security. So it is going to be definitely covered by SD-WAN, and you should know how it is going to work. And then after, how the QS is going to be work, marking, scheduling, queuing, shaping policy, per tunnel, QS, adaptive QS, what that mean, how it is going to be configured. That is going to be done in our entire session. And after that, final touch, we are just going to do some kind of the authentication monitoring, describing how the vManage is centrally monitoring the devices, some REST API, understanding how, what that means with the REST API, how it is like going to helpful in terms of the modern network, and how the software management installation is going to happen. Like I just show the software repository for the upgrading the devices. So this is the entire official syllabus I'm just going to cover, and none of the topic is going to be untouched. This is my guarantee. Okay, entire syllabus is going to be covered. Even you get the more, not less. Okay, this is my commitment. So this is all regarding this syllabus, and I hope all good. Okay. So there is no tomorrow class, guys, and next Saturday, Sunday. So probably next Saturday, Sunday, you guys just coordinate with this Gaurav sir and team. They will just guide you about the exact timing and classes and batches and schedule of my, okay, for upcomings. So all good. Shall we close?
Yeah, sir. We can. So guys, from next Saturday, Sunday, morning 10 or 10:30 is fine. So accordingly, you guys can join.
Yeah. Thank you, Gaurav sir. Yeah. Thank you, everyone. Thank you so much. Okay. Bye bye. Take care. Okay.
Thank you, sir.
Bye bye.